So for the second problem set relating to the steel, we are going to take all the quantities we just calculated for all the different components and then figure out how much it's going to cost us to purchase these items. This will give us a rough estimate of what our steel structure is going to cost. Keep in mind, these are simply made up numbers, so this is not going to be accurate in today's construction industry. So if we wanted to get correct numbers, we could look it up in databases such as RS Means or look at our company history to get accurate costs of what each one of these items is going to be. But for this sample problem, we are going to say that it is $11.95 per ton for our structural steel. Our joists are $925 a ton. And then our metal decking is going to be $824 for every 1,000 square foot of decking. So we'll calculate some of our unit costs, we'll calculate some of our total costs, and then we'll come up with our total cost for the entire steel structure. So starting off, we're looking at the unit cost of a column. We established in the first problem that we have 146.25 pounds for each column. We can multiply that by our cost per ton, but we need to make sure that we convert because pounds and tons are not the same unit. So we can then multiply by 1 ton per 2,000 pounds and get 87.39 as our unit cost. If you wanted to simplify it and simply say that we have $11.95 per 2,000 pounds and not show your two-step process, that is completely acceptable. You're taking your conversion and you're making it into one. Number 12 then is looking at the average cost of our second level beams and girders. So per our average calculation for length, we had 7.0556 feet. If we multiply that by our pound per foot weight, we can get the actual weight for each one of our average beams and girders. And that is what we multiply by the $11.95 per 2,000 pounds. Gives us a total of $42.16 per beam and girder. For the roof plan, it is slightly higher because we have 7.1313 as our average length. We still need to convert it into a weight and then into a dollar amount from that weight. Gives us $42.61. So here we're simply coming up with rough estimates of what we're going to have cost on each one of our different items. Again, these are just average lengths, they're not the actual lengths, so we would have different costs for each one when we're actually doing a full-blown estimate. 14 then is looking at the total weight of all of our steel. So we had our columns that we have from our number 2. So that was 2340 pounds. We had our 1693.33 repeating, and this came from our second level beams and girders. And we had 2353.3 repeating for our roof, giving us a total of 6386.6 repeating, or a total of 6387 pounds. If we want to convert all of this into a cost, we simply take our 6387 or 6386.667. If we use our unrounded number, we multiply that by our 1195 per 2,000 pounds, and we get 0.033, and I just roughly said it's $3,816. That's one way of figuring out our total cost. We could also look at items 11, 12, 13 and take our unit cost for each one and multiply it by the quantity of each item. And then once we have that for each one, we would add them all together. Either way is acceptable, so however you'd like to do it would be fine, as long as you show your work. Next up, we have our joists. So we have our 7.5833 as our average length of our joists. These were 8.5 pounds per foot. Again, it does not tell us in our designation for our joists what that weight per foot is. So we need to know or look it up in a table for that weight. But we have $925 per ton, or $925 per 2,000 pounds. And we get 29.81 as our unit cost. In configuring our total cost, to reference what I was talking about by taking a unit cost times a quantity, we could take our unit cost of $29.81 for each joist, multiply it by the number of joists, we add 24, and we get 715.4875. This is the same thing as if we took our 1547 pounds, that was our total joist weight, and multiply it by the 925 per 2,000 pounds. That will also give us the same answer or close to it depending on rounding. Either way is acceptable. So you don't have to calculate both ways, but if you want to do a quick check, make sure that you actually are doing your math correctly. It is perfectly acceptable to do it both ways. So $715.49 is the total cost for our joist. Our last component is our decking. We have two numbers. We have 470 square feet and we have 588 square feet. This was our actual square footage, and this was our purchase square footage, right? We had to purchase 588 square feet to cover 470 square feet. So which one are we going to use when we do our calculations? Well, the fact that it says purchase should lead you to understand that even if you didn't quite know your answer, the purchase relates to the dollars and cents. So we take our 588 square feet times our cost of $824 per 1,000 square feet, and we come up with 484.512, so roughly $484.51. If you wanted to round up to the nearest whole number and just say $485, that would be perfectly acceptable. And lastly, we're coming up with our total cost for our entire project. So that is our steel, our joists, so the steel meaning our W8x10 beams, girders, and columns, and our decking. So we came up with 3816.04 for our steel. We had 715.49 for our joists, and we had 484.51 for our decking, giving us a total roughly of $5,000. So 5016 is our total cost. Very unrealistic in today's market, very low. So the numbers have escalated a lot, but this is just to show you the steps when it comes to calculating what you would actually purchase and how you apply those costs. We focused a lot on quantity takeoff in this course. We wanted to show you how you can apply pricing so you can get a little further, a little in the step of your estimating to take those quantities and make them into actual dollars that you would purchase. And that concludes the second portion of the sample problem for structural steel.